Hello from Texas. A few days ago it was -6 and now it's t-shirt weather. Let's see if we can figure out about this carbon absorption thing. So here's a spot where the soil is green, but if you look everywhere else, it's kind of dingy and brittle looking. So what's going on here? Well, I put sawdust there, which provides carbon, and then it had animal waste as well, cat litter and such, which provides nitrogen. So let's look at the problem in the most simple of terms. You have natural gas power plants. Well, a lot of your carbon dioxide is emitted to the atmosphere from power plants. I would say somewhere around 20 to 30%. The other large portion is vehicles, but Tesla's taking care of that with the onset of electric vehicles. So now you've got a problem at the power plants, and that's actually a good thing because it's a lot easier to catch carbon from a power plant than it is from a moving vehicle. So what should we do with this carbon, assuming we have the technology to capture it? The big picture system, what are we going to do with it? Well, America and places across the world have millions of acres of barren soil. In some areas the soil is alkaline, in others it's acidic. And in many cases, it lacks carbon on the topsoil. And in many cases, there is no topsoil. The soil has never recovered from the Dust Bowl and the Great Depression in large areas of the United States. Cattle farming is done in a way that is inefficient and messy and really dangerous, actually, for the environment. If it were done in a different way, such as mob grazing or rotational grazing, they call it, holistic grazing is actually the best way, you will get rich green grass growing at a high rate of speed and fertile topsoil just all by managing the cattle properly. So is there a way we could incorporate the power plants into this agriculture system? And really this is the problem. You know, we have the Department of Energy and the Department of Agriculture, but are they really putting their heads together to solve the problems at once? So as I've shown from my previous experiments, the periodic table of elements has a handful of alkali earth metals that are really good at pulling carbon dioxide from air when it's in an aqueous solution. So you're looking at magnesium, calcium, potassium, sodium, lithium, and hydrogen. Hydrogen actually, if you have the hydrogen hydroxide, well, that's water, but it's actually very pure water. So that's the case where you have rainwater and it actually makes carbonic acid, which then hits the soil. You could do the same thing in a power plant. The reason I focus on power plants is because it doesn't make sense to try to pull CO2 out of the atmosphere in areas where it's not concentrated. Such as Bill Gates' machine has a huge amount of fans, and based on my estimates, it's anywhere from 500,000 to 1 million cubic feet of air per minute for 24 hours a day straight just to pull 1 ton of CO2 from the air. Wouldn't it be a lot more efficient to go straight to the source of contamination and get as much carbon from there as you could? So the simple solution is to combine the soil with water and put it into the carbon and pull the carbon. So we need some sort of a system for this. Okay, so here's a hypothetical, but it's a crude sketch. The idea is you have power plant A and power plant B. Both of them have CO2 exhaust with an aqueous, or that is to say water solution that's alkaline in nature or has the right properties and the right chemistry to pull carbon from the exhaust stack. It can put the CO2 into the water stream. Now, suppose you had a parcel of land and it had alkaline soil, has a lot of calcium, but it could use some magnesium. Suppose you have wells and irrigation systems. You pull that water, which is going to be alkaline in nature and have calcium. It picks up the CO2 as calcium carbonate and calcium bicarbonate, and you can pump it over to a parcel of land that perhaps is acidic and could use some calcium. That fixes that land, and perhaps now that we've balanced the soil, the plants will grow better. Now, suppose you have irrigation wells here as well. You can pull some of this more acidic soil from a little bit lower in the depth of the land and take some of that magnesium, and perhaps you can run it through this power plant over here, and with whatever balancing of pH is necessary. It pulls some CO2 and takes some CO2 and magnesium carbonate over to this land. Now, the pH balancing, maybe my design here is off, but I'm just coming up with ideas on how you could essentially do a switcheroo between 2 power plants and 2 parcels of land while fixing the soil in this area and fixing the soil in this area, because both of them need carbon, but the minerals are different. And if you swap minerals, it could improve the soil. Then you can grow more grass, have more cattle, and the cattle will drop more waste, which fertilizes the grass with nitrogen, and then you're pulling CO2 out of the air much more quickly. Green grass can grow year-round in moderate climates. The reason you see it go brown in the winter is not just the cold weather, it's also the fact that the water and the nutrition is not there. So that's one way you could get carbon out of the atmosphere into the ground in a meaningful way. Now, for those of you that don't like the low-tech method, there's always a catch with whatever amazing invention you come up with. Suppose you had a magnesium combustion. You could make a turbine that ran off of carbon dioxide exhaust and molten magnesium, and you would get carbon and oxygen as the output. That would be very powerful, and you could actually increase the power of a power plant, pull carbon. You'd have no carbon dioxide emissions, only oxygen emissions. Wouldn't that be great? But where does the magnesium come from? Well, it comes from the ocean, and somebody has to have another power plant, and they have to run electricity to get it. So how are they making their electricity? So you see, the problem is not something you can solve with an invention. It's something you have to solve with a system. You have to solve it with an overall system. But if there was going to be invention, I think probably one of the best inventions would be something that is like a magic panel, if you will, that takes visible sunlight, converts it from the frequency of visible light to vacuum ultraviolet light frequency, somewhere in the 160 to 200 nanometer range. And that will crack the carbon dioxide exhaust that's pumped through it into carbon dust and atmospheric oxygen. If you could perfect this device, you would have an amazing invention that could pull carbon out of the atmosphere, and it might be scalable, and you've used energy from the sun, so you're not requiring power to run the device. Problem is, you still have carbon dust, and how are you going to put it somewhere? What are you going to do with it? You could store it indefinitely, but it would be best used to put in the soil. If you put that in the soil and stir it around, the soil's going to grow better, and the plants will do better, which even helps pull more carbon from the atmosphere. So you still have a distribution problem, even with a hypothetical invention that is the ideal invention for Elon Musk. Some sort of details on the X Prize is that they want to pull a ton of carbon dioxide from the atmosphere every day, and it has to be stored for 100 years. So I think that maybe my land management water irrigation power plant solution, it's going to be hard to determine if you can really keep the carbon out of the air for that long, but you're improving the soil, which improves the grass, and if you can maintain it for 100 years, you've pulled a lot more carbon out of the air because the grass is in better shape and the trees are in better shape. So that's where I'm at. That's about it. Bye. Yeah, that climate change is a tough sell right now in Texas. Although I gotta say, I've actually kind of enjoyed it. I mean, in a way, it's terrible, all the bad things that are happening, but a lot of people cut off without power, but I try to enjoy things, and getting out in nature in the snow is really cool. But I just wanted to show that your solar panels will defrost faster than other things. And they're still putting electricity into my battery backup for lighting, so not bad. Since my battery went dead in the vehicle, with the solar you got yourself a backup.